So we're starting our new unit today on hydraulics and pneumatics. The first lesson is an introduction to the properties of fluids. Okay, because hydraulics uses fluids, so we need to understand fluids a little bit. First, difference between fluid dynamics and fluid statics. I find a lot of students who come from chemistry who learn a lot about fluid statics, and we naturally know that if you have a container with a fluid, and in physics we consider a fluid to be anything that takes the shape of the container. So that can be either a liquid or a gas. So let's say we put gas inside a container and then reduce the volume. Well, what we're doing is we're putting that gas under a higher pressure. This, I think all of you naturally know this from science at some point in education, but this is fluid statics. Okay, static means being in the same place. So all that fluid is contained inside of that container. Okay, we're going to look also into dynamics, which means, say, a fluid freely moving through a pipe, for example. Okay, so things don't work quite the same way, so it's important to understand the difference between statics and dynamics. Alright, and let's look at, since this unit is hydraulics and pneumatics, what's the difference between those? Hydraulics, right, uses liquids, okay, whereas pneumatics uses air or gases. Alright, so we did a lab when I saw you last in class, and we actually compared both of these. We used sort of two syringes with a tube, and we tried using it filled with air, and then we tried using it filled with water. So one was an example with air of a pneumatic, and the other with water was hydraulic. And what I asked you, which is what you noticed, is hydraulics was much easier at transferring the force because liquids cannot be compressed, right, like a gas can. Okay, so pressure is one of the things we're therefore going to have to talk about. Everything has a certain amount of pressure being exposed on it, unless you throw it into space. Hydraulic system, again, we put liquids under pressure, and a pneumatic system we put gases under pressure, and different things will result. So, here's the reason. I think I just already said this, but let's follow with the PowerPoint. Gases can be compressed. Right? So here we have, we're going to sort of review the particle theory of matter. Here we have a solid, a liquid, and a gas. Solid is rigid, liquids and gases are not, and they both have no fixed shape. So because of those two properties being the same for liquids and gases, we call them a fluid. But there's still a difference between a liquid and a gas. A liquid has a fixed volume. A gas does not, meaning you can change the volume on a gas, which therefore will either increase or decrease the pressure on that gas. Okay, and you will compress the gas, or you will release the pressure. Now you can increase pressure on a liquid, but you can't compress it. So it has a fixed volume. Right? I have it down here. Cannot be squashed, meaning you can't compress it. And because you can't compress it, when we had our tube completely filled, this is why I said make sure there's no air bubbles in there, and we had our tube completely filled with a liquid, when we applied pressure on one side, that pressure immediately passed through the liquid and applied it to the other syringe. If you have a gas and you press down, perhaps the gas in this part of the tube get compressed, and therefore that pressure doesn't get transferred to the other syringe. That's the big difference. Let's continue going over the particle theory of matter, because it's important to understand this to see the differences between liquids and gases, of course, and what will happen to them when we put them under pressure. Number one, all matter is made up of extremely tiny particles. We're good with that. Number two, each pure substance has its own kind of particles, different from particles of other pure substances. So you might remember in grade 9 science, we sort of had you compare pure substances and mixtures, right? Same thing. This would be a mixture, a pure substance, but this would also be a pure substance, right? Because there's only one kind of particle and they're all the same. I don't know which one this is. Maybe that's hydrogen and oxygen combining to create some kind of hydroxide. But they're all hydroxide. This whole thing is filled with hydroxide. This whole thing is filled with hydrogen. But this is filled with hydrogen gas and oxygen gas. So that's a mixture. Particles are always moving. Okay, they can't be at rest. In fact, that's an important thing in physics, specifically quantum mechanics, which we don't study, but quantum mechanics pretty much says you cannot have a particle completely at rest. It's impossible. And you would know too much about it, and that's not allowed. Like, it's literally not allowed in nature. So particles at a higher temperature will move faster than particles at a lower temperature. So that we know. We studied energy, and the definition of temperature, remember, is the average kinetic energy. And kinetic energy is the energy of motion. So if you have more of that, you have a higher temperature, therefore higher motion or speed. And also particles attract each other. Okay, let me just pause here because I've been talking for like 7. Alright, so going back to states of matter. Right? In a solid, particles are moving slowly enough that their attraction actually holds them together in a rigid structure. In a liquid, they're moving fast enough so they won't stay in a rigid structure, but they still kind of want to stay nearby. They're not being shot out on their own. Right? With a gas, okay, they have enough kinetic energy that they're sort of just being shot out on their own. Now you can actually go into a fourth state of matter, which would happen on the sun. It also happens lightning. The temperature gets so high that the electrons are all stripped away from the atom. And then you have the electrons floating around and the nuclei of atoms floating around, and they don't settle together. That's called a plasma, okay, which has free electrons. And because it has free electrons moving around, that conducts electricity really well. Last thing I'm going to talk about, which is again a review. This is grade 9. Don't know if you remember, but we calculated density in grade 9. Density is an important concept when studying fluids. The more dense something that means the more mass they have for some given volume. So the equation for density, which we label with a D, is mass divided by volume. It doesn't have its own units. You just take the base SI units of mass and volume, which is kilograms and meters cubed, and you would write kilograms per meter cubed. Okay, but sometimes we measure volumes in things like liters or milliliters, and 1 cubic centimeter would be the same as 1 milliliter. 1 cubic meter is the same as 1,000 liters. So, I mean, if you want to use a conversion for that, that's fine. That's actually on your handout. Speaking of handouts, let's go to our handout and try a practice problem with density. So here's the comparison I told you. So 1 milliliter is the same as 1 cubic centimeter. So our first question, says a quantity of helium gas at 0 degrees Celsius with a volume of 4 cubic meters has a mass of 0.712 kilograms at standard atmospheric pressure. Determine the density of this sample of helium gas. Alright, So there's some extra information here. We don't really need to know the temperature. We don't really need to know what pressure we're at. If you don't know what standard atmospheric pressure is, that's okay for now. We're going to have a whole lesson later on pressure and atmospheric pressure and gauge pressure. But for now, what we need to know is volume and mass. Because to calculate density, our equation above is density equals mass divided by volume. So let's write this, density equals mass over volume. And we don't need to rearrange this equation. So our mass is 0.712 kilograms. And we don't even need to convert units, right? It's all good for us. Divided by 4 meters cubed. Okay, put that in our calculator. We get 0.178 units would be kilograms per meter cubed. All right, our next question really is comparing terms to their definitions. We had a lot of new terms in this introductory lesson for this unit, so we're going to try and match, make sure we understand the terminology. Okay, so let's look at the first one. A substance that can flow and take the shape of its container. If you know which one this is, type it in the chat. That would help me if you don't say it out loud, because then I would have to edit this video later. Just type it in the chat if you know. A substance that can flow and take the shape of its container. Which one? Yeah, good. Someone said fluid. All right, fluid. Let's try the next one. A fluid that maintains a constant volume. Okay, so it's a fluid, so it's either a gas or a liquid, and it maintains a constant volume, meaning it cannot be compressed. There we go, liquid. Okay, let's try C. A fluid that expands to fill the available volume. This would be our other fluid. Yeah, there you go, gas. There we go, C. Next, the study of the mechanical properties of gases. It's either going to be hydraulics or pneumatics. One of them studies gases and the other one studies liquids. Which one is gases? Pneumatics, good. Right? And then the study of mechanical properties of liquids. This would be the other one. Hydraulics. Yeah. All right, the mass per unit volume of a substance. This is what we just did in question 1. Density. There we go. And last, by process of elimination, compressibility is the property of being able to occupy less volume, okay, which is what gases can do. Just pause, see if anyone has any questions. All right, for our last example, again, this is a density problem, but it's a little bit more tricky. It's not as straightforward as question 1. So here we have a block of metal. It's 0.5 meters long, 0.2 meters wide, and 0.15 meters high. And then it tells us its mass. First, we need to figure out the volume. Now, if you remember to find a volume of something like this, like a block of something, which is a rectangular prism, you have to do length times width times height. Now, these are all in meters, so that's good. If any of them was in centimeters or something else, we'd have to convert it so they're all the same units. But here we have 0.50 meters long multiplied by 0.20 meters wide multiplied by 0.15 meters high. And that's going to give us 0.015, and the units of meters times meters times meters is meters cubed. Then part B says, what's the density? So now that we have volume and they give us mass, now it's similar to the first question. We can say density is mass divided by volume, where our mass is 128 kilograms, and our volume is 0.015 meters cubed. Okay, that's going to give us, and I'm going to put this in scientific notation because it's a bigger number, 8.53 times 10 to the 3 kilograms per meter cubed. Right, and density is what we say is a characteristic physical property. So it's a physical property because it doesn't change what the substance is. It's characteristic because you can use the density of something to identify what it is. So in this case, something that has a density of this is brass. So if you didn't know what that block of metal was before, you know what it is now.